Welcome to part 2, and we're solving the equation 2 cosine theta, or x minus 0. Solve means find out what x is equal to make this a true statement. So I'm going to get cosine x by itself by moving the 1 over and dividing by 2. And now I'm ready to solve that by just looking at my unit circle and finding where is there a cosine of 1/2. So that's the first coordinate. So I don't think it's there, because there you go down the long and up the short. Here it is though. So you go down over the short and up the long, so therefore this is the cosine. The first coordinate is the cosine. So we found one of the answers. That's pi over 3. So then, is there another one? Well, over here, cosine is negative, it's negative. How about down here? Yes. We go over 1/2 and down square root of 3 over 2, but cosine is positive. And you can remember cosine is positive because all students take calculus. So all the trig functions are positive. Sine is positive, tangent is positive, cosine is positive. So in this one, that is, what is that? This is 6 pi 7 6 8 6 9 6 10 6. 10 over 6 is 5/3 pi. Alright, and now we go back and evaluate this one and this one. And we know that we can not only stop here, but we can go all the way around again, or all the way around again. So we indicate that by plus 2 pi, that's one circle, n times. And the same for this one. So that will capture all the possible solutions to this equation. 24. Here we have some letters given. So this is no longer a right triangle. So we were sometimes in trig using triangles that weren't a right triangle. And can't use Pythagorean. So this is going to have this, and this was known as 114. B was known as 37. Little c is 15. And it says find little a. So we can use the law of sines if we have a pair, which is an angle and the side opposite. So we have a pair, so we're going to go with it. Alright, this law of sines is a over sine A equals b over sine B equals c over sine C. Of course, we'll only use them one proportion, 2 ratios at a time. So let's see, let's find this angle before we go into ratios. So this angle A is going to be 180 minus 114 minus 37. So let me get what that is. So angle A (29°). So now in order to find, the question asks us to find little a. So I needed to find the angle across from it. So I'm going to use this proportion along with this one. So setting those equal, I get little a, unknown, but that's what I'm looking for, over sine of 29 equals little c, which I know, 15, over sine of 114. Alright, so we end up with a over sine of 29 .485 equals 15 over sine of 114.914. So little a equals 15 times 0.485 divided by 0.914. So let's see what that is. 15 times 0.485 divided by 0.914. 7.9, and I think they ask us to do 2 decimal places, so I get 7.96. Alright, they have that answer as answer D. Let me see if it's correct. It is. Alright. Number 25 is going to be the law of cosines. So let's see what we got going here. Alright, on number 25, we have A, B, and C again, non-right triangle. Little a is 12. Little b is 5, and little c is 8. So, we're trying, and this time we're asked to find the value of angle B. So, there's several forms of the law. So, the one that I recall, in order to have b in the expression, I have to have little b squared out here on the left equals a squared plus c squared minus ac cosine big B. If you recall, this angle and this side are always in these positions. So, if you're looking for another angle, you could say a squared equals b squared plus c squared minus bc cosine a. And there's another version as well. Let's put in these numbers. 5 squared, 25, a squared, 12 times 12 is 144, c squared is 64, minus a times 8c times cosine b. And we're looking for b in this problem. So this is what we're looking for. So I will calculate 25 minus 144 minus 64. So I get negative 183 equals negative 96 cosine B. Alright, this isn't going to work. Let's see what happened. B squared, B is 25, C is 8, and A is 12. Okay, 25, 144, just checking my work here. I still get that. All right, because